Hello and welcome. This is Dr. Schleif with another worked example, and this one's hot off the request line. The question reads, a digital balance is used to weigh ingredients in a laboratory. When a weight is applied to the digital balance, an electronic circuit generates a current, which is then converted into a digital readout on the display. The electronic circuit gives a current of 2.0 milliamps when a weight of 30 newtons is applied, and a current of 0.5 milliamps when a weight of 5 newtons is applied. Which calibration curve could represent this circuit? All right, well, there's some key information, I think, in the question that we can hone in on right away to eliminate some obviously incorrect choices. The current of 2 milliamps corresponds with a weight of 30. And so we can see that choice A, that matches up, right? We see the current 2 milliamps corresponding with a weight of 30. And choice C also has that back the same, 2 milliamps, 30 newtons of weight. Whereas in choices B and C, you've got 2 milliamps corresponding with 0 newtons of weight. And so both B and D we could eliminate as obviously incorrect choices. The most obvious sort of relationship would be sort of a linear one, and we can see both A and C are not sort of linear graphs, right? They're curvilinear, and so we sort of ask, does the curve inflect this way? In other words, does the steepness of the line drawn tangential to the curve decrease, or is the steepness is the slope sort of increasing as we move along the curve? Well, if we look at the other sort of data point, half a milliamp corresponds with a weight of 5 newtons. Well, if we're a line, then we could just kind of say, well, if half a milliamp was 5, then 1 milliamp would be 10, and 1.5 would be 15, and 2 milliamps would correspond into 20 newtons, but it doesn't. It tells us that 2 milliamps is actually 30 newtons. So we're not sort of getting up to the weight that we need to quickly enough, right? And so because weight is graphed on the horizontal axis, what we're looking for is for sort of a tinier change in the current, a greater change in the weight, right? In other words, so as we rise, we want a longer run, right? We want the steepness of the slope drawn tangential to the curve to decrease. And so A is the correct answer here. Only A has that property where, if half of a milliamp here corresponds to 5 newtons, as we sort of climb up this curve, we need to get further and further along the x-axis for sort of a change in the current there. And so you can kind of just think your way through that with the values that are presented, and also holding up sort of a sort of non-example, right? Like I said, like just assume that it's linear and just say, well, prove to yourself why that wouldn't work. And so, well, what do we need to do instead? And it's very obvious that A is the only correct answer to this problem. This has been another worked example with Dr. Schleif, still living the physics life. We'll see you next time.